Okay, so the fact that we have a graph of f is the first thing that I want you to kind of gravitate toward. You have a graph of f, but the difference here is you have g of x set equal to this f of t because of the fact that you have an x for that upper bound and you have t. So you have an integral with two different variables. And the ones that you'll see are t and x. Already, this should be screaming at you right now that this is going to be second fundamental theorem. At some point in time, you're going to need g prime of x. And how did you do that? Well, you basically took the derivative of the left side to get g prime of x. And guys, you tell me, by looking at the right side in the practice that we've done, what's the derivative of the right side? F of x. Just curious, what if it looked like this? What would the derivative of that be? Negative f of x. Good. Okay. So with this in mind, chances are we're going to need this for second fundamental theorem. And now, let's go ahead and go through the problem. The first thing that you're asked to find is g of negative 6. And what some people have done is they'll say mistakenly that g of negative 6 is equal to f of negative 6. What is it that they've mistakenly done right there? That's g prime. G prime is f of negative 6. So if you want to find just g of negative 6, we'll just plug in the negative 6 right here for x and integrate. So g of negative 6, the y value on g, which we can't see, at negative 6 will be equivalent to the area underneath the graph of f from negative 2 to negative 6, and then we're integrating f of t dt. So when it's g, guys, when it's g, we're looking at f of t. Y'all with me? But when it's g prime, we're looking at f of x. Either way, f is f. It's still the same graph. Okay? All right. So my setup right now, what is wrong, quote unquote, with this setup? I need to flip the bounds right now, because I'm supposed to integrate low to high, especially with the graph. Otherwise, I'm going to miss stuff by negative. And a lot of people miss that negative on the one that we had this weekend, okay? So let's flip the bound. So it'll look like low to high. And because we just did that, the laws of integrals, we have to account for it there. Okay? So here we go. This is saying let's find the area, bless you, underneath the graph between the x-axis and this graph, between negative 6 and negative 2. So here we go. All of this area is what we're looking for. And we're going to look at this as normal, and then at the very end, whatever we get, multiply it by a negative. Okay? So anyone, what is the area right now of this?
10 units squared.
Say again?
10 units squared.
10 units squared. So it's 1/2 times base times height. The base is from negative 2 to negative 4, which is 4, or negative 2 to negative 6. And it's 1/2, and the height looks to be 5 because of that y value there. So you get 20 divided by 2, you get 10 units squared. That's the area. And this area represents the y value at negative 6 on g. The only thing that I need to do with this 10 is what? Multiply by this negative. It's a positive 10 at first glance. Why? Because it's above the x-axis, and all areas above the x-axis are positive. But because we changed the bounds and we flipped them, it's actually going to be a negative 10. So g of negative 6 equals negative 10. If you wanted to put it like a point off to the side, you could say negative 6, negative 10. This is your xy. Okay, so now let's do g of 3. G of 3, and if we use straight up just the equation that they gave us as far as the area this one right here, we're going to set it up as g of 3. The y value on g at x equals 3 equals the integral from negative 2 to 3 f of t dt. Do I have to do this flip trick with what I see right now? No, because it's low to high. So let's find the area underneath, oops. We're going to find the area underneath the graph of f between negative 2 and 3. There's area, and there's area. Okay, so the first one is the circle. It is pi r squared. Can anyone tell me what the radius is? 2. So what's the area of the top one? 2 pi, because right now this would be 4 pi, but this is a semicircle, so it's pi r squared divided by 2. Is it positive or negative? Why? It's positive, but why? Because you're above the x-axis. Okay? And so this is going to be positive 2 pi, and then we have to account for this area here. And this area looks like it's 1/2 times the base of 1 times the height of 2. You with me? What's this area right here when I multiply all those out? 1. But because it's underneath the x-axis, it's actually what? Negative 1. So what's my final y value equal to? 2 pi minus 1. And I know this looks weird, but it's saying the y value on g at 3 is 2 pi minus 1. That means the point would look like this. Okay, and this is non-calculator. This is the number 5, so you won't be able to do that. 2 decimals. Okay, so now that we have our 2 y value points, let's keep going. Are there any questions, though, so far from what we've done? Okay? So again, when you change the bounds, read as normal. What's above the axis is positive, what's below is negative. And at the very end, if you change them, then constant multiple roll that negative.
So there is negative area.
Yes, there could be negative area. Because here's the thing. The area underneath f is equal to the y values of g. And you tell me, on a graph, do you ever have any negative y values? Yeah. So that's why you can't have negative area per se in this case. What 2 words would be mentioned in the question that would negate the negative area? Area bounded. If it said area bounded. But see, this never said find the area bounded, because then it would be positive. It said find the y value on g at negative 6, which is equivalent to the displacement area. And displacement can be negative. Okay? Are we good?
So if it says area bounded, you take the positive area of everything?
Yeah, you just, everything, area bounded is the absolute value per se. Yeah. Okay? Alright, so let me see, because I need to go to the question. The second question says find g prime of 0. Okay? I don't want to scroll up and lose all this work. Okay? So the second question says, let's find g prime of 0. Okay, guys. We started off this question knowing we were going to possibly use the per second fundamental theorem. So in part B on your answer document, I would begin with all this work and put per second fundamental theorem, and we're going to say g prime of 0 is actually equal to what? F of 0. So whatever f of 0 is, that's the same as the slope on g at 0. Okay? Can anyone tell me what f of 0 equals? 2. So some people look at this, they look at this, and for some reason they mistakenly think that they're trying to find the derivative on f at 0, which is not the case. I just want you to tell me what the y value on f is, because that is equivalent to the derivative on g. So yes, g prime of 0 is equal to the y value of 2 on the f graph. Okay? Yes? Oh, I thought you had a question. Next one says, The graph of G has a horizontal tangent at x is equal to -2 and 2. Oh wait, my bad. It says find all values of x on the interval from -6 to 3 for which the graph has a horizontal tangent. And then we're going to justify as far as if it's a local max, a local min, so on and so forth. So first of all, let's break this down. We want to find horizontal tangents on G. Okay, so if we're looking at G and we're looking, come on, and we're looking for a horizontal tangent, what are we saying? Yeah, so we're trying to find when G prime is equal to 0. Where? Oh, or sorry, G prime of x is equal to 0. That's what we're looking for. And again, I know that I'm doing this, and I'm going to write it down because it might be one of those points that they give us. Okay? So G prime of 0 is equal to, G prime of x is equal to 0. That's where the horizontal tangents occur. Guys, do we have a G graph? We don't have a G graph. We have a G prime graph. So is this the same as this right here? Yeah, so this right here is synonymously saying that f of x is equal to 0. That's what you're looking for. Can someone tell me when f of x is equal to 0? -2 and 2 in some other place. 6. Okay? And it said between -6 and 3. So would you include the -6? No. So you're only going to put -2 and 2. So x equals -2 and 2 are where basically f of x is equal to 0. Per second fundamental theorem is the same as saying where G prime of x is equal to 0. Okay? Here we go. Now, if we're analyzing this, and my critical points are -2 and 2, remember, we were trying to find this. Can someone tell me, since I'm doing a sign test right here, what would go here? G prime of x. Because you're trying to find, is it a relative max, is it a relative min, or is it neither? What else could I put here instead of G prime of x? F of x. Okay? So now I'm putting f of x because we're tying that relationship between G prime of x and f of x, because we're going to analyze the signs for G prime of x by looking at f. Okay. So to the left of -2, what's the sign? It's positive. Why is it positive? Because the graph is above the x-axis. How about between -2 and 2? It's positive. Why? Because it's above the x-axis. Not the area, because the y values are above. And then finally, after 2, guys, what is it? Negative. Again, we're seeing between -6, not including that, and 3. So we have positive, positive, and negative. Okay? Can someone tell me, what is it going to be at x is equal to 2? What kind of a max? It'll be a relative. So you will say, and I'm not going to write it for the sake of time because I'm going to do other problems. You would say there is a relative max occurring at x is equal to 2 for what? First derivative test, because G prime of x, otherwise f of x, changes from positive to negative. And then you would say neither at x is equal to -2 because the signs don't change. But you got to say the signs of f of x or the signs of G prime of x. How's that? Good? Okay, let's go to D. D says find all the values of x between the -6 and the 3 for which the graph of G has a point of inflection. So we're looking at the same domain per se, but now on G I'm trying to find where the points of inflection. Here we go. On G of x, where do the POIs occur? When I see POIs, already I'm going to which derivative? The second. That means I need to look, where does G double prime, what? Change signs. Because if G double prime is positive, it's concave up. G double prime is negative, it's concave down. And anytime they change signs, there's my point of inflection. Okay. Guys, do you see a G double prime graph? Nope. Can someone tell me what this is equivalent to? It's the same as, let's go back one level. This is synonymous by saying G prime changes from what? Increasing to decreasing, that would be positive to negative, or the other way around. Negative to positive. Okay? So this is what you would have to state. Do we have a G prime graph?
Yes.
We do, but it's not written as G prime. Because of second fundamental theorem, which we will place again in part D, we know that a relationship occurs between the f of x graph and the G prime. They're the same. So you could say you're looking when f of x changes from increasing to decreasing, vice versa. That will tell you where the POIs occur on G. Okay? So on that interval, it's going to be here, here. Are there any others? 0. Any others? That's it. So you would say point of inflections occur on G of x at x is equal to -4, 2, and 0. Per what? Definition of point of inflection. Because what? F of x changes from increasing to decreasing or decreasing to increasing. And we know that per second fundamental theorem, that's the same as saying G prime of x would change from increasing to decreasing or decreasing to increasing. Which what we have relationship identification between derivative levels is that decreasing versus the sign changes. And that goes back way to that table when we first started off by saying if f of x is increasing, that means f prime of x is positive, and so on and so forth. Questions before I close this out?
What if it asks to find the maximum, maximum points on that graph? Not the relative maxes, but
The absolute.
Yeah, absolute.
So if it did the absolute, and if it asks the absolute, default immediately, you're not doing first derivative test anymore. What are you going to do? Candidates test. Here we go. So the candidates test, this is a good question. If it asks for max as far as absolute or global, we would look at, and what would it say? Like the max on G, wouldn't it? It would say not on F, but the max on G. So let me change this real quick. There we go. We got to find our candidates. And from this graph, guys, what are two candidates that you can see already? -6 and 3. Why are these two candidates? Because they're endpoints. Okay? So now all the in-betweens, we need to find where G prime equals what? 0 or undefined. On this graph, where does G prime of x equal 0? -2 and 2. Guys, do you see on this graph where it's equal to undefined? Some people say this. Why would they say that? Because they're looking at cusps, they're looking at endpoints. But I'm asking you, When is g prime of x otherwise f of x per second fundamental theorem? When is it 0? Well, we said at negative 2 and 2. But when is it undefined? What would that look like on the graph? It would a removable discontinuity or a vertical asymptote. You with me? Like it wouldn't exist as a domain. You wouldn't see a point. Okay? So all you have to do now is you would plug into G. Look, here's your G graph. You would plug in negative 6, which I think we already did at the very beginning, didn't we? What did we get? Do y'all remember? Did y'all write it down? Negative 10. Then what did we get on 3? Didn't we do 3? 2 pi minus 1. Now you would just have to put negative 2 here. Guys, what is it going to be at negative 2? 0, because there's no displacement. And now, from negative 2 to 2. Julie, I appreciate you asking this question, okay, because it's extra help on this as well, okay? From negative 2 to 2, we're looking at what is the area, which is otherwise the y value on G. What did we say that one was? 2 pi. And someone, can you tell me what, out of all these, let me ask you, be careful, where does the absolute max occur? X equals 2. What is the absolute max? 2 pi. Understand the subtleties of what they ask and how they ask it. I think that's it on this question. Okay, nicely done.